The purpose of the introductory activity is to find the molarity of a potassium permanganate solution. The purpose of this is so that later in the lab, when doing an oxidation reduction reaction through titration, we can find the percentage of hydrogen peroxide in a standardized solution.
The purpose of the Day 2 activity is to find the percentage of hydrogen peroxide using the sample model created in the introductory activity.
Now this is a model safety student. Because sulfuric acid and potassium permanganate are used in this lab, a lab apron and safety goggles must be worn at all times. Sulfuric acid is highly corrosive towards skin, and potassium permanganate is an irritant towards skin and eyes. Remember to wash your hands with soap and water before leaving the lab.
Here's a 50 milliliter burette being held up by the ring stand with the burette clamp. It contains 50 milliliters of potassium permanganate. Remember that burettes must be filled to the 0 milliliter mark, which is unique of a burette. Here's the 250 milliliter Erlenmeyer flask, which contains 1 milliliter of hydrogen peroxide, 10 milliliters of deionized water, and 10 milliliters of sulfuric acid. In the beginning of the lab, we will add 1 milliliter of potassium permanganate to the solution of hydrogen peroxide. Remember that after each milliliter is added, you must swirl the solution so that the hydrogen peroxide can react with the potassium permanganate.
When potassium permanganate is on the sides of the flask, you have to rinse and swirl to make sure that all the potassium permanganate reacts with the hydrogen peroxide. This will not change the concentration of the solution. Instead of titrating 1 milliliter at a time, as we approach the endpoint, it is important to titrate more slowly to ensure that we do not overshoot the endpoint.
As you can see that the color of the solution is no longer changing, the endpoint has been reached.